So welcome to another part of the numerical series. So in previous part, I have given this question. So let's see. So the question says a vertical sedimentary column is measured from the present day surface downward. The last occurrence of fossil species P, it is 40 million year, occurs at about 25 meter, and the first occurrence of fossil species Q, that is dated 65 million year, occur at a depth of 70 meter. So suppose we will take this much as 70 meter. So here we have fossil Q, which is 65 million year old. 65 million year old. Then fossil species P occurs at a depth of 25 meter. So this much is your 25 meter depth. Here we will find fossil P, which has an age of 40 million years. Then there is another volcanic ash bed that is found at 45 meter depth. Take another 45 meter depth. Here we have an ash bed. So assuming constant sedimentation rate, no structural depletion or missing of section, that means the deposition from Q to the surface is completely continuous. There is no age gap or uniformity or any type of structural deformation. So we have to determine the rate of sedimentation in meter per million year. Meter per million year. Let's see. Q has an age of 65 million year, present at a depth of 70 meter. Okay. P has an age of 40 million year, it present at a depth of 25 meter. So as the sedimentation is continuous, that means the deposition from P to Q will take deposition from P to Q will take 65 minus 40 million years, 25 million years. Will be 25 million years. Now the thickness, or we can say the width from P to Q will be thickness from P layer to Q layer, it will be 70 minus 25, it will be 45 meters. Now see, 45 meter deposited in 25 million years. So I have to calculate the sedimentation rate. So the rate of sedimentation is asked in meter per million year. That means how many meter deposited in 1 million year. So that will be 45 divided by 25 meter per million year, 1.8 meter per million year. 1.8 meter per million year. Then question asks calculate the radiometric age of the volcanic ash bed. So volcanic ash bed is present at a depth of 45 meters. You know, from P to Q also 45 meters. Okay, so 45 meter it is deposited in 25 million years. That means as the sedimentation rate is constant, then this 45 meter will also deposited in 25 million years. That means the age of the ash bed is 25 million years. The sedimentation rate is 1.8 meter per million years, and your age of the volcanic ash bed is 25 million years. Let's come to another type of problem, that is your escape velocity. So first, you know the formula of escape velocity. So escape velocity of any planet, it will be 2gm by r root over. So where g is the universal gravitational constant, m is the mass of the planet, r is the radius of the planet. So here we have taken to calculate the escape velocity of the earth. So velocity escape, it will be 2 gm by r. 2 g is 6.67 into 10 to the power minus 11. Then mass of the earth is 6 into 10 to the power 24 divided by radius is given 6.4 into 10 to the power 6 root over. Answer will be in meter per second. Answer will be in meter per second. Now we'll solve this. 2 into 6.67 into 6 into, it will be 13, then 6 to 10 to the power 7 divided by 6.4 root over. So it will be 1183.1346 meter per second. If you convert it into kilometer per second, it will be 11.18 kilometer per second. So escape velocity of earth, 11.2 kilometer per second. So it is constant. Remember, the escape velocity of earth is 11.2 kilometer per second, that calculated in this way. Next comes to another, that is escape velocity of the moon. I will apply the same formula. Velocity of escape of moon will be 2 gm by r. Here the planet is that is m, and r is your radius of the moon. Mass is the moon. Mass is the mass of the moon. 2 into, then gravitational constant is 6.67 into 10 to the power minus 11 into mass is 7.3 into 10 to the power 22 divided by radius of the moon is 1.74 into 10 to the power 6 root over. So it will be 2 into 6.67 into 7 divided by 1.74 will be 11, it will be 10 to the power 5 root over. So it will be 2353.01 meter per second. So in kilometer it will be 23.53 kilometer per second. So it is the escape velocity of the moon. This comes to another problem. So this type of question already asked in IIT-JAM previous year. So we have a hypothetical planet X has mass 4 times than the Earth of 4 times that of the mass of the Earth. So we'll take hypothetical planet X has mass, suppose mx, which is 4 times than the mass of the Earth. Okay, then and a radius 2 times than that of the Earth. So we'll take radius of X, it will be 2 times radius of Earth. So calculate the escape velocity from the surface of the planet X, or you can say in another way, how many times the planet X has escape velocity than the Earth. This type of question can be asked, or you can ask what is the ratio between the escape velocity of planet X and planet Earth. So the formula is, suppose velocity, escape velocity of planet X will be 2 g mx divided by rx root over. So we'll put g, so mx equal to 4 me divided by rx equal to 2 re root over. So you can write down like this, 2 g me divided by re, the root over into 4y to the root over. Now this one is your velocity, escape velocity of the earth into root 2. So we know escape velocity of earth is 11.2 km per second. So we have already calculated into root 2. 15.83 km per second. Or you can say the velocity of planet, escape velocity of planet X is root 2 times the escape velocity of planet Earth, or their ratio will be root 2 or 1 by root 2. So next is also a similar type of question, so you can pause and try to solve it. So here we have a hypothetical planet Y. It has mass equal to 1/2 of the Earth mass. So mass of the planet Y is equal to half of the mass of the Earth, and a radius equal to 1 by 4. That means radius of planet Y is equal to 1 by 4th of radius of Earth. So we'll put the formula velocity, escape velocity of Y equal to 2g_my divided by r by root over. So it will be 2 into g, then mass of the Y planet is half of the mass of the Earth, so it will be 1 by 2 me divided by 1 by 4th re. So from the same condition, will 2g me divided by re root over equal to into same 4 by 2 root over. So escape velocity of Y equal to escape velocity of Earth into root 2, which will be same 15.83 km per second. Understood? Next, come to another type of problem, that is your average atomic mass. This also asked in previous questions in IIT-JAM. So first we'll know what is the formula of average atomic mass. So average atomic mass equal to summation of isotopic mass into fraction of isotope. So let's solve this problem. So chlorine occurs naturally as 2 isotope, chlorine 35. So chlorine has mass 35, which is abundance, that is 75%. Chlorine that has mass 37 has abundance of 25%. So I have to calculate the average atomic mass. So average atomic mass, your atomic mass is given, one is 35, one is 37. Then abundance, the percentage is given 75% and 25%. So we'll take the summation, that is 35 into 0.75 plus 37 into 0.25. So it will be 35.5 atomic mass. This will be the average atomic mass. With the average atomic mass of the chlorine. So next is also a similar type of question. So try to solve this. So you have a hypothetical element X existing 2 isotopes. Atomic mass is given 10 with abundance of 40%, and isotope B atomic mass unit is 11 with a abundance of 60%. So average atomic mass of X, it will be 10 into 0.4 plus 11 into 0.6. It will be 10.6 AB, atomic mass unit. Next comes to another important type of question, that is your bifurcation ratio. So bifurcation ratio, it is calculated by bifurcation ratio. So number of stream in one order divided by number of stream in next higher order. So U is the order of stream, N is number of stream. So in U, that is number of stream in particular order divided by number of stream in next order. That means if, let's say in example, number of stream present in first order divided by number of stream present in second order. So this is the bifurcation ratio. So let's try to solve this. So we have given the number of first order stream is 64, number of first order stream is 64, number of second order stream is 16. So bifurcation ratio, take RB for bifurcation ratio, that is 64 by 16, it will be 4. Will be 4. It is very easy numerical. Either the number of stream is given, otherwise sometimes in question you have given a diagram from which you have to count the number of first order stream or second order stream, then solve this problem. Then the number of stream of different orders in a drainage basin are given. So first order, second order, third order given. We have asked the bifurcation ratio, that is mean bifurcation ratio. So first order stream, N1 is your 100, N2 is your 25, N3 is your 5. So first we'll calculate the bifurcation ratio from N1 to N2, then N2 to N3, then we'll take the mean or average. So from N1 to N2, so we'll take RB1 to 2, that is 100 by 25, which is 4. Then RB2 to 3, that is 25 by 5, which is 5. So we'll take the average. So average will be 4 plus 5 divided by 2, will be 4.5. So mean bifurcation ratio will be 4.5. So if there is more order, then you'll calculate like this. Then you'll just take the average of the bifurcation ratio that will calculate it. That will be called as your mean bifurcation ratio. So next question, it is the drainage basin of fifth order. So there is a drainage basin which has the highest order of number of stream is fifth. Then the highest order of stream is fifth. The mean bifurcation ratio is given 4, and you have to calculate the number of second order stream. There is a formula for this. Number of order U will be equal to mean bifurcation ratio to the power S minus U. So NU number of stream of order U. Then RB is your mean bifurcation ratio. Mean bifurcation ratio. Then S is the highest order of the basin. So S is the highest order of the basin, RB is the mean bifurcation ratio, and NU is the number of stream of order U. So you have to calculate the number of stream of order U. So here given the drainage basin is fifth order, that means S equal to 5. Then the mean bifurcation ratio, it is given, RB is given 4, and calculate the number of second order, that means U is given 2. So you have to calculate NU. So it will RB to the power S minus U. So that means 4 to the power 5 minus 2. that is 3. It will be 64. So the number of second order stream present in this basin is 64. Next also similar type of problem, so you can try to solve this. So S is given, highest order is given 6, bifurcation ratio is given 3. So you have to calculate the streams of fourth order, that means U is your 4. So NV number of stream in fourth order, it will be RB to the power S minus U, which will be 3 to the power 6 minus 4, will be 3 to the power 2, will be 9. So the number of stream present in fourth order will be 9. So it is very easy. So just you have to remember this formula. So then comes to another type of problem, that is seismicity of the river. So in mature stage, river mostly do lateral cutting. So that's why it produce seismicity in its path, which we called meander. If the seismicity will be more. So how we will calculate the seismicity? It will be channel length divided by valley length. Suppose you will take from point A to point B. So the length along the valley, it is called as your valley length. The length along the valley is called as valley length. That is the actual length, and the straight distance between these 2 points are called as valley length. So this is your channel length, and this is your valley length. So this is your channel length, this is your valley length. So from that you can calculate the seismicity of the river. So let's solve first question. So the actual length of the channel of the river is given 18, while the straight line or valley length between its source and mouth is 12 km. Calculate the seismicity of the river. So seismicity will be channel length divided by valley length. So it will be channel length is 18 divided by 12. So it will be 1.5. The drainage density, it is a very important numerical. So drainage density, how it is calculated? Drainage density is equal to length of all stream present in a basin divided by area of the basin. So the drainage density will be length of all stream present in a basin divided by area of the basin. So it has a unit, you can say length inverse. So let's solve this problem. A drainage basin has a total stream length. Total stream length is given. Drainage density total stream length is given 250 km, and the area is given 500 km square. It will be 0.5 km inverse. That is drainage density. Next question. A river has an actual length of, same question from seismicity. So seismicity, it is calculated by channel length, that is given 24 divided by valley length given 16. Will be also 1.5. Seismicity will be 1.5. Similar question also, this seismicity will be 30 by 25, is also 1.5. So these are for practice, so that you can remember the formula. Next comes to another type of problem, that is rate of incision, or you can say rate of erosion. So, so incision rate it will be depth of the valley and age of the. So here in question, a river has insides for 200 meter. So incision rate will be 200 meter divided by 40,000 year. So it will be meter per year. So but answer is asked in mm per year. So 200 meter will be 200 into 10 to the power 3 mm divided by year divided by 40,000. That is 5 mm per year. It will be 5 mm per year. Next also similar type of question. So incision rate will be 150 divided by 30,000. This is meter, this is in year. So I have to calculate in mm per year. So it will be 150 into 10 to the power 3 divided by 30,000. It will be also 5 mm per year. 5 mm per year. Okay, let's move to next. Also a similar question where length of the basin, length of the all stream is given 300, 150. It will be 2. So density will be 2. The density will be 0.5. So these are for practice, you can say, so that you can remember the formula. So next move to another type of question, that is your stream power. So what is the formula of stream power? Rho QGS. So stream power, then rho is density of water or fluid, Q is discharge, then G acceleration due to gravity, then H is your slope. So rho density of water, Q discharge, that is meter cube per some time, G your acceleration due to gravity, which is 9.8 meter per second square, H is the slope. So let's solve this problem. River at discharge, Q is given 20 meter cube per second. Channel slope, it is given 0.002. You have to calculate the stream power. We will take rho as 1000 kg per meter cube, and we will take G as 9.8 meter per second square. So stream power will be rho QGS. So rho, it will be 1000 into Q 20 into G 9.8 into S is 0.002. Then units are your meter cube per second, then kg per meter cube, then meter per second square. Meter cube will be cancelled. It is kg into meter divided by second cube. You can write down like this: kg into meter square divided by second cube into meter. So kg per meter square into second cube, it is what? So watt per meter. So unit will be in watt per meter. So let's solve this. 1000 into 20 into 9.9 into 0.002 will be 392 watt per meter. 392 watt per meter, that will be the stream power. So next also same type of problem, try to solve this. So stream power will be rho Q G S. So rho is your density of the water, that is 1000. Q is given here 50, G is 9.8 and slope is given 0.1 and unit will be watt per meter. So this will be 4900 watt per meter. 4900 watt per meter. So next comes to another type of question, that is your Brewster's angle. So what is a Brewster's angle? So it is an incident angle for light for which the reflected ray and refracted ray are polarized and the angle between reflected and refracted ray is 90 degree. So that is called your Brewster's angle. So for this incident angle, it will the ordinary light will be polarized. So we calculate the Brewster's angle by this formula, tan inverse n2 by n1. There is also a derivation for this, you can refer to an optical metrology video. So theta b equal to tan inverse n2 by n1. So we have to calculate the Brewster's angle of light incident from air to glass. So air to glass means n1 is your air, n2 is your glass surface which has a refractive index of 1.5. So we have to calculate theta b, that is your Brewster's angle, that will be tan inverse 1.5 by 1 will be 1. So 1.5 by 1, it will be 1.5. So tan inverse 1.5. It will be 56.309 or 56.31. This much degree will be your Brewster's angle. If you incident the light at this angle, then the reflected ray or refracted ray are polarized. The same question. So we have to calculate the Brewster's angle, that is theta b, which will be tan inverse from air to water, that means air has 1, that will be tan inverse 1.33. So it will be 53.06 or you can take 53.1 degree. This much will be your Brewster's angle. Then comes to critical angle. So we already have discussed this. The critical angle is the angle of incidence for which angle of refraction is 90 degree. So we have to calculate the critical angle of light traveling from quartz to air. Quartz to air. So critical refraction only occur when light travel from denser to rarer medium. So light traveling from quartz to air, that means quartz is your n1, air is your n2. So you have to calculate the critical angle. So theta c is equal to sine inverse n2 by n1. So it will be sine inverse n2 is given, n2 is your 1, n1 is your 1.54. Let's see. So it will be sine inverse 0.649, will be approximately 40.466, or if you round up to 2 decimal, it will be 40.47. The next question also similar type of question, where light from calcite to air, where the calcite has a refractive index of 1.66. So theta c will be sine inverse 1 by 1.66. So it will be sine inverse 0.602 and the answer will be 37.01 degree. 37.01 degree. So let's come to another type of problem, that is your Bragg's law. So Bragg's law used to determine the interlattice spacing that is your D. Suppose this is one lattice layer, this is another lattice layer. So in ray of light incident on the lattice layers, so this will be your theta. The help of this we will calculate the spacing between the lattice plates, that is your D. So the formula says n lambda equal to 2D sin theta. N is your order of light, lambda is your wavelength of light, then D is your lattice spacing, or interplanar lattice spacing you can say. Then theta is your Bragg's angle. You can say it's a glance angle. So now we'll solve this problem by using this formula. So X-ray of wavelength 1.54. So lambda is given 1.54 refracted by crystals Bragstrom by crystal at Bragg's angle of 30 degree. So theta is given 30 degree and in fast order, that means n is your 1. So you have to calculate the interplanar spacing. We'll put the formula n lambda equal to 2D sin theta. So D will be n lambda divided by 2 sin theta. So n is 1, lambda is 1.54, then 2 is sin 30 degree. So it will be 1.54 angstrom. Similar to the wavelength. So next also a similar question. So try to solve this. So here the wavelength is given 1 angstrom. We put the formula n lambda equal to 2D sin theta. So wavelength is given 1, our incident crystal having interplanar spacing is given 2. Find the Bragg angle for first order reflection. So first order means this is 1. So n is given 1, lambda is given 1 angstrom. That means this side will be 1. So we have to calculate the D. So theta. So sin theta will be n lambda divided by 2D. So D is given 2 angstrom. So n will be 1, lambda is 1 divided by 2 into 2, that is 1 by 4, 0.25. So theta will be sin inverse 0.25. It will be 14.477. Again 14 point, if you round up to 2 decimal, it is 14.48. Next also same type of problem. We have a second order reflection n equal to 2 and a Bragg's angle, that is theta is given 45 degree. Interplanar spacing is given, D is given 1.5 angstrom. So you have to calculate the wavelength, that is lambda. So n lambda equal to 2D sin theta. So n is 2 into lambda we have to calculate. 2 into D is given 1.5 angstrom, then sin 45. 2 will be cancelled. Then lambda equal to 1.5 into sin 45. It will be 1.06 angstrom. Will be approximately 1.06 angstrom. So next come to another type of question, that is your phase difference. So phase difference, there is a formula equal to 2 pi d by lambda. So d is your retardation, lambda is your wavelength. So it is retardation or called as path difference. It is retardation or called as path difference. So let's solve this problem. The monochromatic light of wavelength 600 nm. So lambda is given 600 nm, producing a retardation of 300 nm. So retardation that is your D is your 300 nm. So you have to calculate the phase difference. So the phase difference will be 2 pi d by lambda. So 2 pi d by lambda, 2 into pi into d is given 300, lambda is given 600. So it will be only lambda, or you can say 3.14. 3.14 will be your answer. Let's come to second question, same type. Light of wavelength 500 nm. So lambda is given 500 nm. Phase difference is given, that is phase difference, it is given pi by 2. So we have to calculate the retardation. So phase difference is given pi by 2 equal to 2 pi d, 2 into pi, we have to calculate the d divided by lambda is given 500. When 500, pi will cancel, then d will be 500 divided by 4, it will be 125 nm. Will be 125 nm. So next comes to another type of problem. It is from your previous year question. So it is asked about numerical aperture. So it is related to resolution of the microscope. So resolution of microscope, it will be lambda by 2 Na. So lambda is wavelength, Na is your numerical aperture. Okay, let's solve this problem. A light of wavelength 500 nm. So lambda is given 550 nm. Having a numerical aperture is given. Numerical aperture, that is Na is given 0.85. So to calculate the resolution, that is lambda by 2 Na. So lambda is 550 divided by 2 into 0.85 nm. It will be 323.529, 323.53, this much nm. So remember this formula, so you can easily solve this type of problem. Next, same type of question. So I have to calculate the resolution. Here wavelength is given 600 divided by 1.25 is your numerical aperture into 2, and so it will be mm. So it will be 240 nm. 240 nm. So next comes to fixed carbon percentage calculation. It is a very easy numerical. So just remember the formula. So fixed carbon percentage to be calculated by 100 minus percentage of moisture in the coal plus percentage of ash in the coal plus percentage of volatile matter. So you have given here moisture is 8%, so 100 minus moisture is 8, then ash is 12 plus volatile is 30. It will be 50%, 100 minus 50, it will be 50%. So it is very easy, just you have to remember this formula. Then it is a one-step calculation. You can also calculate this by using the same formula, 100 minus 5 plus 10 plus 25, which will be, this much will be 35, it will be 65%. Okay. This is also same. Phase carbon ratio percentage will be 100 minus 12 plus 8 plus 28. It will be 48. So answer will be 52%. Then this is also a very easy question. A coal sample of 50 gram loses 4 gram on drying, but with the moisture content. So it is a very easy, or you can say straight question, or it can be twisted like this. A coal sample has weight of 50 gram, then after removal of the moisture, reduces to this much. Then you can take, you can suppose this is 50 gram coal sample. After drying, weight reduces to 46 gram. So it loses 4 gram. So you can calculate from this also, or it can given straight to you in the question, so it will be more easier. So moisture content, it will be weight loss divided by weight of the sample, into 100 percentage. So moisture content in this question, weight loss is 4 by 50 into 100. 4 gram by weight of the sample is 50 gram. So it will be 8%. It will be 8%. Then these are also similar type of problem. So just for practice. So I'll write down the answer. This will be 5%. This will be your 7.5%. So try to calculate by yourself. The answer will be this much. So next comes to another type of problem, that is your liquidity index and plasticity index. So plasticity index is calculated by is your liquid limit minus plastic limit. The liquidity index, it is calculated is your natural water content minus plastic limit divided by plasticity index. Divided by plasticity index. So the plastic index first will be calculated, then you can calculate the liquidity index. So let's solve this problem. A soil sample has a liquid limit of 50%. So liquid limit is given. I'll write down LL in short form. With 50%. Plastic limit is PL. Write down 25%. And natural water content, that is W, is 35%. So first we will calculate plasticity index. So I'll write down PI for plasticity index. It will be liquidity index minus plasticity index. Sorry, plastic limit minus liquid limit. Sorry, liquid limit minus plastic limit. 50 minus 25, it will be 25%. Then you have to calculate the liquidity index. So the liquidity index will be W minus plasticity limit divided by plasticity index. So W is given here 35. 35 divided by plastic limit is your 25 divided by plasticity index is also 25. So it will be 10 divided by 25. So it will be 0.4. 0.4. So liquid index it will be 0.4 and plastic index it will be 25%. So next two are the same type of problem. So first try to solve this. So first we'll calculate first we'll calculate plasticity index. It will be liquid limit which is 70%, plastic limit is 30%, so 70 minus 30 it will be 40%. Then we will calculate the liquidity index, which is your natural water content is given 50% minus your plastic limit, that is 30% divided by 40. 20 by 40 it will be 0.5. Be 0.5. Next question also like this, plasticity index it will be liquid limit minus plastic limit, 40 minus 20. Natural water content, that is W is given 25, so it will be 20. So liquidity index will be W, that is 25 minus, so plastic limit is 20 divided by, it will be 20, it will be 5 by 20, it will be 0.25, it will be 0.25. Then comes to calculation of bulk modulus. So bulk modulus it is calculated by pressure divided by volumetric strain. That means del V by V. Del V is your change in volume, V is your original volume or initial volume, V is applied pressure. So let's solve this problem. A rock sample has initial volume is given 1 meter cube. When subjected to uniform confining pressure of 50 MPa, its volume decreases by 0.002 meter cube. That means this is the del V, change in volume. Volume is given decreases by, that means this is the change, that is the del V, and this is the initial volume 1 meter cube. So let's solve this. Bulk modulus pressure is given 50 MPa divided by del V is your 0.002 divided by V is your 1. So bulk modulus will be 25,000 MPa. We can convert it into gigapascal, that is 25 gigapascal. With 1000 megapascal is equal to 1 gigapascal. Next question also similar type of question. So during laboratory testing, sandstone specimen initial volume is 0.5 meter cube, experience a volume reduction of 0.0005 meter cube when the applied stress is increased by 20 MPa. So bulk modulus pressure is given 20 MPa divided by change in volume is 0.5 divided by 0.5 will be 20,000 MPa or your 20 GPa. This comes to your calculation of Poisson's ratio. So it is lateral strain divided by longitudinal strain. Or you can say transverse strains by longitudinal strain. So in this question, longitudinal strain is given 0.004 and lateral strain is given 0.001 divided by 0.004 0.25. So most of the rock they have a Poisson's ratio of 0.25. So this is also similar type of question. So an axial strain is given 0.005. So Poisson's ratio so it will be lateral strain, that is 0.0015 divided by 0.005 will be 0.3. Will be 0.3. This much is for today's video. So on the next part, we'll continue from isostacy problem.